What is the pH of a solution prepared by mixing 50 milliliters of 0.1 molar ammonia with 25 milliliters of 0.1 molar ammonium chloride? Assume the volume of the solutions are additive and that K sub B equals 1.8 times 10 to the negative 5 for ammonia. So the equation that I'm going to use for this problem is the Henderson-Hasselbalch equation. So I'll write out what this equation generally looks like. And so before I start solving this, I'm going to set up the reactions that are occurring so I can get a better understanding of what's happening. So we have this aqueous solution of ammonium chloride, and that is going to dissociate into ammonium and chloride ions. So I will write out that dissociation reaction. So this is our ammonium and our chloride. So this will undergo complete dissociation. The second thing that's happening is that now that we have ammonium, this ammonium will act as an acid in water. So I'll write out the reaction that's occurring. Ammonium wants to be in its stable form. So it wants to be ammonia. So it'll donate a hydrogen to a water molecule, and this reaction will produce ammonia and hydronium. So now that we have a better sense of what's going on, we can start solving the Henderson-Hasselbalch equation. So the second thing that I'm going to do is just find pKa, because that is the first term in our equation. So we're given Kb, and we can find Ka using this relationship. We know that Ka times Kb equals Kw, which is 10 to the negative 14th at 25 degrees Celsius. And unless stated otherwise, I would say that it's a safe bet to assume that your reaction is taking place at 25 degrees Celsius, so you can use this relationship. So now that we have that, our Ka is just going to be Kw over Kb, and I get that it equals 5.56 times 10 to the negative 10. And then to find pKa, this is just the negative log base 10 of Ka. And so I end up getting that this equals 9.255. So now that we've found that, we can find the concentration of HA and the concentration of A minus, which is also in our equation. So looking at our reaction that's occurring here, we know that HA is acting as our acid, so HA is going to be ammonium. So this is our concentration of ammonium. And A minus is just the conjugate base of this acid, which again, looking at our equation, is just going to be ammonia, which is what is formed when ammonium donates a hydrogen to our water molecule. And this is just equal to the concentration of ammonia. So we're actually given enough information in the problem statement to find these concentrations. So I'll start with finding the concentration of ammonium. We're told in the problem statement we have a 0.1 molar concentration of ammonium chloride. Well, we know from our reactions that we wrote out that ammonium chloride completely dissociates into ammonium and chloride ions. So the concentration of ammonium that we have is also 0.1 molar. So we have 0.1 molar, which is just 0.1 moles per liter. And then to find the initial number of moles that we added, we know that this was in 25 milliliters of solution, which is just 0.25 liters of solution. So now we have the number of moles that we added initially. And to find the concentration after the two have been mixed, we're told that the volumes of the solutions are additive. So now we're going to divide by the total volume, which is 0.075 liters or 75 milliliters. And I get that the concentration of ammonium is 0.033 molar. And in a similar way, we can find the concentration of ammonia. We also have 0.1 moles per liter. And then we have 50 milliliters of that originally. So that's just 0.05 liters. And then again, we're going to divide by the total volume because this is after they've been mixed. And I get 0.067 molar. So now that we have that, we can just plug into our equation. So I get that the pH is 9.255 plus the log of 0.067 divided by 0.033, which is equal to 9.56.